Assalamualaikum and good day. My name is Muhammad Lutfi Fitri bin Muhammad Roslan, CF100137. And now, I would like to present about the introduction. A slope failure occurs when the self-retainability undermines the rainfall or earthquake, it causing the slope to collapse unexpectedly. There are 4 types of the failure. First one is the rotational failure, is the translational failure. Third one is the compound failure, and the fourth is the wedges failure. Now, we will look at the issue in engineering that caused the slope failure. The first issue is inadequacy in design due to the lack of knowledge and comprehension of surface condition and geotechnical concern. The second issue, the construction defects, and the third issue, guideline appears to be very comprehensive, where it is too hard to the authorizing authority to apply since it open to multiple interpretation. The slope engineering practice can be done by first, criteria or subsurface investigation. Second, analysis and design. Third, full-time site monitoring. And last but not least is routine maintenance inspection and engineering inspection. And now, let's proceed to the literature review. What is the slope salability analysis can be defined? From what I know, slope salability analysis can be defined as the study of probable failure mechanism and their sensitivity that can trigger the event. Then, we will look to the technique of slope stability remediation. The first technique is the geometrical method. The second technique is drainage method, and the third technique is the retaining structure method. For the slope stability analysis, we have 3 methods. The first method is limit equilibrium method. The second method is finite element method, and the last method is numerical method of modeling. Among all of the limit equilibrium approaches, we can say that the ordinary slice method gives the most conservative calculation of factor of safety value. Other limit equilibrium approaches is more realistic calculation interstate force that may emerge in reality. The factor of safety of the critical slip surface is calculated automatically using the finite element approach. And last, the finite element approach solves the equilibrium and the compatibility equation from the elasticity theory. And now, my friend will proceed to the next presentation. Thank you.
Assalamualaikum and hi, my name is Muhammad Aziz Yusri bin Rusidi and my metric number is CF190037, and today I will explain about the technique of slope stability that has been proposed for this project. A soil nailing is a steel rod encast in cementinous grout that is used to transfer tensile pressure from the unstable active zone of the soil mass to the stable passive zone. Soil nails placed close together to generate a huge soil nail interaction inside the soil mass of a strengthening. Soil nail may be observing with a spacing ranging from 1 to 2.5 meter in both horizontal and vertical direction. A component design of soil nailing, there are 5 components, which is nail element, ground strength, nail head strength, flagellal strength, and facing element and connection. Construction aspect of soil nailing. Number 1, drilling equipment. Number 2, grout mixing equipment. Number 3, shotcreting or garnetting equipment. And lastly, compressor. These are the material that has been used in soil nailing method, which is steel reinforcement, grout mix, and shotcrete or granite. And next, I will go to the construction sequence. Firstly, initial excavation. Next, we go to the drilling of hole, and lastly is insertion of nail reinforcement and grouting. And next, I will explain about the work program on soil nailing, which is the contractor must design a work schedule based on the actual production rate of the equipment. A reasonable provision must be made for the delayed output while drilling through rock or bedrock. And next, need to be a QA/QC testing, which is pull out the testing, both are preliminary and operation, grout mix cube specimen, shotcrete and cube strength testing panel, tensile strength of a reinforcement and coupler, and lastly, check the steel reinforcement galvanizing thickness. Thank you.
Assalamualaikum, my name is Muhammad Afiq Nur bin Syarizan, CF190142. So I will present my part is application of any standard. Normally, a value of 1.00 will result in slope failure. Refer to this the Public Work Department PWD 2010 guideline for slope design, the FOS for slope in Malaysia, shows in the table below. For the unreinforced slope, you can see here the local and global stability 1.3, bearing 2.0, and for the reinforced or treated slope, the local and global stability 1.5 and the bearing is 1.5 also. So the designer responsibility. The designer must search for and study all reports on feasibility studies, development plans and investigation related to the works in order to fully comprehend the factors that may affect the works. For the survey data, the designer shall conduct detailed topographical, hydrologic, and land surveys of the proposed site and areas that may be affected by the works as needed to supplement available survey information for the satisfactory design and construction of the work. For the soil investigation, the preliminary site investigation result is provided by the client are only to be used as a rough guide. For the design data, all detailed design must be accompanied by a summary of the field exploration and laboratory investigation result. For the earthwork, field material used in the construction of field slope and embankments must go to the greatest extent possible be excavated from adjacent cuts. For the settlement analysis shall be carried out for the field slope and embankment depending on the subsoil condition encountered. Slope stability analysis. Stability analysis for the temporary stability measured during construction. Cut and field slope stability analysis should include both circular and non-circular analysis and in multi-mode of failure. Any slope that is influenced by surcharge load shall be analyzed taking into consideration of the surcharge load. Field slope and embankments. All untreated field slope and embankment must have a minimum factor of safety of 1.3 and a berm width of 2 meter and height of 6 meter. When the design is inadequate, stabilization measure can be considered. The following are example of stabilization measure. First, geogrid or geotextile reinforcement. Second, reinforcement concrete retaining structure. Third, reinforced field structure. And the last one, replacing the fields with elevated structure. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Before I start, let I introduce myself. My name is Aiman Hafifi bin Rosli. My matrix number CF19001C. In this part, I will present about long-term stability for the purpose technique. Okay, the initial safety factor and the improvement after strengthening will usually be assessed using a slope stability program, using either the limit equilibrium approach or the strength reduction method in finite element analysis. Such stability assessment must be carried out in place where there is a risk of human harm. If slope instability develops, should be factor will determining stability. The modeling of soil nail in most commercial software is sometimes restricted to applying a constant point load to the slope surface and where the soil nail is located. The pre-stress is immediately delivered to the slope surface and there is no load transfer between the free land and the slope destabilizing mass. For this technique is appropriate for ground anchoring. It's worth noting the nail resistance change depending on where the slide surface intersect the dead nail. In order to establish a valid safety factor in a limit equilibrium stability evaluation, the individual nail load for each slip surface should be modified. It's vital to use an interactive procedure to change the individual nail load based on the key slip surface intersect until the safety factor converges. For the first picture, this picture the typical type of failure mechanism. There's a three type of failure: internal failure, mixed failure, and external failure. Okay, for the second picture, okay, this picture shows the adjustment of soil nail load with respect to a specific slip surface. Okay, for the first table is a table for recommended factor of safety for new slope for a 10-year return period rainfall. And for the second table is using to recommended factor of safety for various failure modes. Okay, these two tables was using to determining the safety for soil nailing. Okay, that's all from my part. Okay, now I will pass to my friend to explain a conclusion from this project. Thank you.
Hi, my name is Muhammad Zulfazi bin Alman. My metric number is CF190176. So for the conclusion of this project, we can conclude that the purpose of this study is to identify the cause of slope failure at Bukit Antarabangsa, Ampang, Selangor. We find out by the case study that frequent increase in the groundwater table as an outcome of uncommonly heavy rains will increase the pore water pressure of the soil. It also causes in the shear strength of soil, which is also affect the stability of the soil and cause the slope failure at Bukit Antarabangsa. We find out that the method to remedial slope failure that we use by using soil nailing method. This method treat unstable natural soil slope or as a construction technique that allows the safe over steepening of a new or existing soil slope. We find out that this is a suitable method to overcome the slope failure or landslide by improving the slope stability for a long term. The landslide or failure slope also can be triggered by several factors that can be minimized by providing a risk management strategy to overcome it. That's all. Thank you.